Right, now we're going to look at, here we have a graph that's been plotted, a straight line graph. So we know that it's going to have the form y equals kx plus m, where k is the gradient and m is the intercept, where it cuts the y-axis. So let's start with the easiest thing, which is the intercept. Where does this line cut the y-axis? Well, we can see that we've got to go up plus 5 here. 1, 2, 3, 4, 5. This must be point 0 here. And 1, 2, 3, 4, 5. This must be point 0 in the x-axis and the y-axis. So 0 in the x-axis, 0 in the y-axis. And now we just need to count down then. So if this is 0 and this is plus 1, this one must be minus 1, minus 2, minus 3. So the straight line cuts the graph, cuts the y-axis at the point minus 3. So we now know what the value of m is. It actually has minus 3. In order to work out k, we need the gradient. So k is the change in the y divided by change in the x. Or we can write it as y2 minus y1 divided by x2 minus x1. The delta sign here just means change in. Or you can write it as being the rise divided by the run. So the gradient is k, and we can express it in any of these ways. Delta y over delta x, y2 minus y1, rise over run. Now we have to choose two nice simple points on our graph that we'd like to say which ones is our y1 and which ones is our y2. Well, I think it's nice and easy here, at this particular point here. This is a good point. It cuts the graph very nicely at minus 3. And another good point, it would be up here, where we can see that at the coordinate 4 in the x and 5 in the y, it goes exactly, crosses that line. Okay, so now we just need to work out how high is the graph compared with how far we've gone in the x-axis. So let's have a look. From this point to this point, how many steps have we taken? So we just draw like a little triangle here and say, right, how many steps have we made in the y-axis? We've gone from, up here we've got plus 5, and down here we have the coordinate 0, minus 3. So we've gone from 5 all the way down to minus 3. So the y2 position is 5, and the y1 position would be minus 3. So we take the difference of those, divided by, so this one here, the difference in this y coordinate minus the difference in this y coordinate, which is 5 minus minus 3, which is 8. Divided by the difference in the x-axis. Well, here we've gone from 0 in the x-axis, and the x-axis here has gone to 4. So we've gone from 0 up to 4. So the difference in x2, which is up here, is 4 minus 0. This one is x2, y2. And this one down here, our first point, is x1, y1. 4 minus 0 is 4. So we get that the gradient, k, is 8 divided by 4, which is 2. This is the mathematical way of doing it. Another way of doing it is just to think, okay, if you find that that's a little bit complicated, think rise over run instead. We're just counting how many steps have we gone from this point down here to that point up there on the y-axis. And we've gone 1 step, 2 steps, 3, 4, 5, 6, 7, 8. We've gone 8 steps up. And we're counting in steps of 8. And then if we think, how many have we gone in the x-axis? Well, we've moved from 0, 1, 2, 3, 4. So we've gone 4 steps across. So we divide our 8 steps that we went up with our 4 steps that we went across, and we get the gradient of 2. So we now know that k is 2, so we now know that our equation will always have the form y equals 2x minus 3. Once we've worked out that equation, what we usually do when we're doing graphs is we actually write it on the line. Y equals 2x minus 3. We're telling anybody who reads our graph that this line can be represented by the equation y equals 2x minus 3. We go 2 steps up for every one we go across. If we go along 1, we go 1, 2 up. If we go along 2, we go 1, 2, 3, 4 up. So it's just telling us how many steps we go up compared with how many steps we go across. We're going 2 steps up for every one we go across when we get the equation 2x minus 3.